All right, our next piece is to look at some rules for limits of sequences. If you know how sequences behave, more particularly if you know how limits of sequences behave, then you can use what you know about the behavior of any one particular limit to be able to put that together to any particular sequence. Then you can figure how a different sequence from that will behave. So here we go. Suppose we're given sequence AN, and that limit is L. We're given another sequence Bn, and that limit is K. So AN has a horizontal asymptote at L. Bn has a horizontal asymptote at K. So the limit of A is equal to L, limit of B is equal to K. All right? And C is any real number you want. So piece number one, what is this? What is the limit as n goes to infinity of C times AN? If I have a constant times a sequence, if I have a constant multiplier, the question is, what does the constant multiplier do? The constant multiplier multiplies along. The constant multiplier multiplies along. And so if I take C times the function and evaluate the limit, it's the same thing as C times the limit. So the constant what this rule says is you may move the constant multiplier out in front. Constant multipliers multiply along. Find the limit, then multiply. Constant multipliers multiply along. Number one, constant multipliers multiply along. Constant multipliers multiply along. Number two says what's the limit of AN plus BN? What's the limit of the sum? The limit of the sum. Well, we've investigated this with the limit of the sum for ordinary functions. The limit of the sum is the sum of the limits. Well, these are ordinary. They're not ordinary, but they're functions. The limit of the sum should in fact be the sum of the limits. And so yes, indeed, we do have the property that the limit of A plus B is the limit of A plus the limit of B. This is true for plus. It's also true for minus. It's true for plus. It's also true for minus. So the limit of A plus or minus B is the limit of A plus or minus the limit of B. The limit of the sum is the sum of the limits. The limit of the sum is the sum of the limits. Constant multipliers multiply along. The limit of the sum is the sum of the limits. Our next property is number what? Number 3 we're at now. This is the limit of AN times BN. What is the limit of the product? The limit of the sum is the sum of the limits, but the limit of the product is the product of the limits. This is the limit as n goes to infinity of AN times the limit as n goes to infinity of BN. The limit of the product is the product of the limits. The limit of the product is the product of the limits. And then number 4, so if you add, the limit adds along. If you subtract, the limit subtracts along. If you multiply, the limit multiplies along. And if you divide, if I have AN over BN, then yes, that's going to be the limit of AN over the limit of BN. Now, when I write this, we have to assume several things. We must assume this denominator is never 0. We need to assume that denominator is never 0. So assuming, with fractions, you always need to assume no denominators are 0. With that proviso, then these statements are true. The limit of the sum, limit of the difference. Limit of the sum, limit of the difference. Limit of the multiple is the multiple of the limits. Limit of the fraction is the fraction of the limits. And here's where these L's and K's come in. Remember, anytime you see this symbol, you can write that as L. Anytime you see this symbol, you can write that as K. So this is the limit of the A plus the limit of B is L plus K, or minus. We could have L plus or minus K. Because L is the first limit, K is the second limit. We could write this as L times K. L times K. We could write this as L over K. Again, assuming K is not equal to 0. So remember, L is just the shorthand for that big expression. K is just the shorthand for that big expression. But the big picture is limit of the sum is the sum of the limits. Limit of the difference is the difference of the limits. Constant multipliers multiply along. Limit of the product is the product of the limits. Limit of the quotient is the quotient of the limits, assuming there are no zeros in denominators. And so those are just the basic properties of working with limits and how they all get put together. And so we can talk about the convergence or the divergence of these kinds of functions, and we can work with the limits just the same way we have worked with limits in our functions that are continuous.